Okay, so we did limits last year. We're going to keep looking at limits this year. So we'll start with the definition of a limit. So the definition of a limit says that the limit as x approaches a of some function is always equal to just some constant number. And then we also have one-sided limits, where either you're just looking at it from the positive direction or you're looking at it from the negative direction. So if you're looking at the limit as x approaches a from the positive direction, that means you're looking at it coming from the right. So you're starting over here and going this way. If you're looking at a limit from the negative direction, so as x approaches a from the negative direction, you're looking at it from the left. And then we do have infinite limits, and what that means is that we have asymptotes at those parts. So if the limit as x approaches a of any function is infinity or negative infinity, then we know that the line x equals a is a vertical asymptote. Okay, so we're going to go way back to our algebra skills when trying to solve these limits. The easiest way to solve a limit is just to use direct substitution. If direct substitution doesn't work, then our goal is to try to simplify the problem. And if neither one of those works, then we're going to estimate our limit using a graph. Okay, so back at example 1. I'm asked to find the limit as x approaches 1 of x minus 1 divided by x squared minus 1. Right, so the first thing we want to try is direct substitution. So that just means that I'm going to plug in 1 everywhere I see an x. So if I did that, I would get 1 minus 1 divided by 1 squared minus 1. Okay, well 1 minus 1 is 0. 1 squared minus 1 is also 0. And you can't divide by 0, so I know that direct substitution doesn't work. Leave me alone. You interrupted my class for a pre-absence form? I have class. Jalen, you can come grab it. Or not. Alright, so if direct substitution doesn't work, then we're going to try to simplify. And so if I look at x minus 1 divided by x squared minus 1, the easiest way for us to try to simplify something with a squared is to see if it's factorable. And so I'm going to see if I can factor the bottom. And I know that x squared minus 1 factors to x plus 1, x minus 1. So my new problem is x minus 1 divided by x plus 1 times x minus 1. So then my x minus 1's cancel, and I'm left with 1 over x plus 1. So I was able to simplify my problem. So if I try direct substitution again on my simplified problem and plug in 1 for x, I get 1 divided by 1 plus 1. And 1 plus 1 is 2, so I get 1 divided by 2, or 1/2. So since I actually get a number solution, then I know that that's going to be my limit. So my limit as x approaches 1 of that equation is 1/2. Don't be that easy on the assignment, I swear. They're not too bad. Okay, so if I look at example 2, the limit as x approaches 0 of the square root of x squared plus 9 minus 3 divided by x squared. Well, if I try direct substitution and plug in 0 for all my values, I get the square root of 0 squared plus 9 minus 3 divided by the square root of 0 squared. And if I simplify the bottom, 0 squared is just 0. And I know I can't divide by 0, so I'm not even going to waste my time simplifying the top. Direct substitution doesn't work. The next thing I can try is to simplify it. And so square root of x squared plus 9 can't be simplified or factored. And x squared is just as simple as it gets. So since there's nothing I can do to this to make it simpler, I can't simplify. So the last thing I'm going to do is estimate it using a graph. Okay, so if I go to graph that equation, I get the square root of x squared plus 9 minus 3 divided by x squared. Alright, and I want to know what my value is at approximately 0, so I'm going to zoom in around to 0 to see if it'll give me a better answer. And so I can kind of see that my graph is just up in between 0 and 1 somewhere. And so if I want to estimate a value close to 0, I know like that the value 0.01 is really close to 0, right? So we'll just estimate 0.01 and see what it gives us. And it gives me y equals 0.166666662. And so if I round that to 2 decimal places, then I know that my limit as x approaches 0 of the graph is equal to 0.17 approximately. And then we're also going to look at one-sided limits today, because there are times when we're only looking at a limit from a certain direction. So I'm given this function g of x, and I'm asked to find the limit as x approaches 2 from the negative. So that means from the left. So I'm going to be looking at the graph going from the left. Okay, and so I can see when x equals 2 that there's two different values on my graph. But since I'm looking at it from the left, I'm caring about the curve that's coming on the left side of that point. And so what is my y value equal to on that part? 3. So my limit is just 3. If I'm looking at the limit as x approaches 2 from the positive side, I'm looking at it from the other direction, from the right. And so I care about the curve that's to the right of that point. And so what would be my limit if I'm looking at the part where I'm going to the right? What's my y value there? At that point, what's my y value? 1. Okay, so my y value would be 1. Okay, so then graph C asks me just to find the limit as x approaches 2. So that cares about when it's going from both directions, because I wasn't given a directional limit. And the easiest way to figure that out is to look at your two limits that you were given. So we know from the left it equals 3, and we know from the right it equals 1. Since those are not the same number, we say that the limit with no direction does not exist. In order for your limit to exist, both from the left and the right, they have to be the exact same value. Okay, so if I do the same thing with my limit of g of x, I'm looking at my limit as x approaches 5 from the negative, so from the left. So if I go over here to 5, I care about what I'm approaching, what point I'm approaching as I go from the left. And so what's my y value at this point? 2. And if I do the same thing for as x approaches 5 from the positive, then I'm looking at it from the right. And what value does my graph approach if I look from the right? 2. And so then, if I look at my non-directional limit, just the limit as x approaches 5 from both directions, are these numbers then the same? Yes. So then, I know my limit is just 2. Alright, and then the last one that we're going to look at is the limit of 1 over x squared as x approaches 0. So again, you'll start with direct substitution, which actually usually works, but hasn't worked on any of our examples so far. So if I plug in 0 for x, I get 1 over 0 squared. And 0 squared is 0, so I get 1 divided by 0, which doesn't exist. If I try to simplify it, the only thing that I can simplify it is an x squared, and I can break that down to x times x. But again, that doesn't really change the problem, so simplifying it doesn't work. So then we're going to graph it. So if I graph 1 over x squared, then I get this very weird graph. And so if I go to where x is equal to 0, what do I notice about my y value at that point? Well, I can keep zooming out. If I keep zooming out, I just know that my graph is just continuing to go up along my y-axis, but it never actually touches my y-axis. And so what does that tell me about my limit? It does exist, but it's one of our unique cases where our limit is equal to infinity, positive infinity, because it's going on and on forever and ever and ever. If it looked like this, then we would say that that was a negative infinity limit. But since it's going up into the positive direction, you see that it's positive infinity. And what does that tell me about the point x equals 0, the line x equals 0? At infinite limits, what do we know about those points, those lines? X equals a is a vertical asymptote. Okay, so anytime you get limits of infinity or negative infinity, that tells you that those lines are asymptotes, vertical asymptotes. All right, so 1.5 is page 59, 4 to 7, 13 to 14, and 29 through 37.